Cisco Catalyst switches use several different types of tables to assist in the switching process. Two of these specialized memory architectures that we're going to compare are the CAM and TCAM. CAM stands for Content Addressable Memory, and all models of Catalyst switches use a CAM table for layer 2 switching. As data frames arrive on a switch port, the switch will learn the source MAC addresses correlating to that traffic, and it's going to record those MAC addresses in the CAM table. This is done so that next time there's a frame destined for a specific MAC address, the switch knows exactly how to deliver that and the switch port that it should use to do so. The entry recorded into the CAM table includes the port number, the frame arrived on, and the source MAC address associated with the frame, and also the timestamp for the frame's arrival. CAM tables are large, but they are finite. So on a large network, it's completely possible to run out of CAM table space. That's the reason that the timestamps are recorded. In order to manage what are referred to as stale entries, or addresses that have not been heard from in quite some time, the CAM table entries are automatically removed after a particular aging time, and by default, any CAM table entries that are idle for more than 300 seconds will be deleted. Now, this can be changed very simply from global configuration mode on a switch with the command MAC address-table aging-time followed by the number of seconds that you want to set the aging timer to. If a MAC address learned on one switch port suddenly appears on a different switch port. Maybe someone's plugged their laptop into another cubicle in the office, as an example. The port, the MAC address, and the timestamp are going to be recorded for this most recent occurrence, and the old entry will be deleted immediately. That purge happens in order to avoid having duplicate CAM table entries. Otherwise, the switch may be confused when it makes switching decisions. Now, as we've already said, the CAM table can learn those addresses dynamically from incoming frames, which is the default action, but you can also configure static CAM table entries as well. During CAM table lookup, the table will provide one of two results, either a true or a false. So either a MAC address will be found in the CAM table or it will not. Those are the only two possibilities with CAM tables. In binary, this will either be a 0 or a 1 value. So it's going to look for an exact key consisting of binary numbers during the table lookup process. Another memory table used by switches is the TCAM, the ternary content addressable memory. Some layer 2 switches will contain a TCAM for quality of service usage, but primarily we see TCAM in multi-layer switches which have layer 3 capabilities. If you think about traditional layer 3 routing, one of the ways that we control traffic is through the use of access control lists, or ACLs. These ACLs will contain entries that will either permit or deny traffic based on certain rules that we determine. So for example, maybe we have an ACL denying traffic from a specific IP address. When traffic arrives from that IP address, this traffic would be evaluated against the access control list, and if a matching statement is found, the traffic would be dropped. So we can think of an access list as a very common function that uses TCAM. So it uses those ternary content addressable memory tables in the exact same way that we're talking about here. And they do that in order to perform packet matching using wildcard values. The TCAM is essentially an extension of the CAM, but where the CAM can only return two results, either a true or a false, a match or no match found, in other words, the TCAM also has a third state called the any value or the do not care value. So during lookup, this leaves three values, 0, 1, and X. X is the do not care value. These three values are where the table gets its name, as the term ternary is defined as a mathematical value based in 3. So instead of performing exact match searches, the TCAM can perform a broader search based on pattern matching and wildcards. The entries in the TCAM have a particular format referred to as VMR, value, mask, and result. The value refers to the pattern that is being matched, which can include IP addresses, protocol ports, and so on. The mask refers to the mask bits associated with the pattern. So with ACLs, we assign a wildcard mask to our entries. These types of masks are used in TCAM lookups in order to determine which bits are of interest to us. And the result are numeric values that action which should be taken after TCAM lookup. Those can include permit, deny, QoS policing, next hop forwarding, and so on. If we connect to a live interface and we run the command show MAC address -table, this is going to display the contents of our CAM table. Here we can see the MAC address, we can see whether that was dynamically learned or statically learned, and we can see the VLAN number as well, and we can see the ports that those are connected to. We can also specify that for a particular VLAN or interface if we want to by just appending those keywords to the command. We can see the size of the CAM table by using the command show MAC address -table count. And that's going to show the number of dynamic and static addresses that have learned and the total number of MAC addresses that have been learned. You can also see the total MAC address space available, which is pretty huge. We have a lot of those available for us. So these are going to show the MAC address totals for each active VLAN. In this case, I only have a single VLAN on this lab topology, so it's only showing those for VLAN 1. This command output is going to give you a really good idea about the size of the CAM table and even the number of hosts on the network. If we want to view information about the TCAM, now I can't do this with Cisco Viral. That's not supported at this time. But if we wanted to do that, if we had a layer 3 capable device that could do that, we could say show platform TCAM utilization. That's the command we could use, and that would show us the overall utilization for that TCAM. So that's a look at the difference in the CAM and the TCAM. Again, to reiterate, all layer 2 Cisco Catalyst switches use the CAM, while the TCAM is typically seen in multi-layer switches and routers. We do see that in some layer 2 switches for use with QoS enforcement, but by and large, whether the switch is a layer 2 or a multi-layer device will usually determine which type of table is available on the device.